Today's lesson is over solving two-step equations. We just finished up solving one-step equations. Now we're going to see what happens when we add a couple other things in there. It's really important to understand that you need to follow order of operations, and then when we solve, we're going to undo those order of operations. But first, let's take a peek at a couple of these examples up at the top. You should have your notes packet open to this page and should be copying down as I'm going. Okay, just like I said, to solve an equation, it's important to first note how it is formed. Then we have to work backwards to undo each operation. In this equation, 4z plus 3, we're multiplying by 4 and then adding 3. So to solve, we're going to subtract 3 and divide by 4. It's kind of undoing everything, undoing the order of operations. In the second one, we have z over 4 minus 3 equals 7. Z is divided by 4 and then subtracted 3. So that means we're going to have to add 3 and then multiply by 4 to solve. Notice how when we're solving these two, the last operation we're going to be doing is undoing that multiplication and that division. But over here on this third one, it's actually a little bit different. When you are listing what's happening to your variable, you do need to follow order of operations, which typically means that when you have multiplication and division, it's going to go ahead of addition and subtraction. Except for this example, this last one here. Notice how the vinculum, that fraction bar, is extending all the way underneath z plus 3. That fraction bar is acting as a grouping symbol, parentheses, which means that we are actually adding 3 first, then dividing by 4. So to solve, we've got to multiply by 4 and then subtract 3. A little bit backwards. Let's go ahead and get started on these examples down here. There are 5 of them that we're going to work through together here today. I'm going to show you how to fill in these sentences and then also a tool called clues and undos. First of all, let's list what's happening to the variable according to order of operations. So the variable is multiplied times 3 and then subtract 5. So we multiply by 3 and then subtract 5. To solve, we're going to undo that last operation first. And to undo it, we have to use the inverse. Inverse of subtraction is addition. And then the inverse of multiplication is division. So to solve, we're going to first add by 5 and then divide by 3. Let's go ahead and write this equation down here in your workspace. 3x minus 5 equals 7. We're going to do a table called clues and undos. The clues are what's happening to your equation according to order of operations, and undos are how we're going to go about solving this equation by undoing our order of operations. Just like we said in our sentence, the first thing that we're doing to our variable is multiplying it by 3. Then we're subtracting it by 5. When we're solving on our undos, we're going to work up from the bottom up. To undo subtraction, I'm going to be adding 5 to both sides of the equal sign. And then to undo my multiplication, I'm going to be dividing both sides by 3. Let's go ahead and draw our line down our equal sign. Show that we're going to add 5 to both sides. Draw my line to do my math. That minus 5 plus 5 goes to 0, just like in our one-step equations. So I've got 3x equals 12. By undoing that subtraction part, I've now gone from a two-step equation to a one-step equation. 3x equals 12. You all know how to solve that one. just go ahead and divide both sides by 3, which shows over here, matches what we put on our undos. We added by 5, now we're dividing by 3. 3 divided by 3, 1's out. We're left with x equals 4. Let's just do a quick mental math check by plugging 4 back in. 3 times 4 is 12. Minus 5 is 7. So winner, winner, chicken dinner, that's the correct answer. The second example has division and addition in it. We're still going to fill out our sentences. The variable is divided by 3, and then we add 5. To undo, to solve, we're going to first subtract by 5 and then multiply by 3. Let's go ahead and rewrite this equation down here. Oops. And let's do our clues and undos. I'm going to go ahead and abbreviate the clues and undos. According to my equation, I have division and addition as it's written on the equation. Following order of operations, I'm going to divide by 3 first, then add 5. But to solve it, remember we have to work backwards, and we're going to be undoing that order of operations. So to undo adding by 5, I'm going to subtract by 5. And to undo division of 3, I'm going to multiply by 3. Let's go through and show those steps. Subtract 5 on both sides. 5 and negative 5 go to 0. I have x over 3 equals 2. It's back to a one-step equation. I'm going to follow that last undo clue that I told myself. And I'm going to multiply both sides by 3. There's 1 out, so I'm left with x equals 6. Quick mental math check. Plug 6 back into your original equation. 6 divided by 3 is 2, plus 5 is 7. Winner, winner, chicken dinner. Question 3 is one of those tricky ones. We have to be very, very, very careful because it's formed a little bit differently. Notice how that vinculum, that dividing by 3, is underneath both the x and 5. Anytime you see that, I want you to add those grouping symbols. I want you to add those parentheses, which means that we're actually adding 5 to x first. So it says 5 is, I think what mean is 5 is added to x, and then the result, whatever we get, is divided by 3. Say hello to my cat. So to solve, we're going to have to undo that division of 3 by multiplying by 3 and then subtracting 5. Let's rewrite the equation. That's Aggie purring in the background, by the way. He likes solving equations too. We're going to do clues and undos. Remember, that numerator, x plus 5, is grouped together. It's kind of like invisible parentheses. When we're following our clues and going in order of operations, we have to list that we're going to be adding 5 first, then dividing by 3. My undos, involve multiplying by 3 and subtracting by 5. I'm going to work from the bottom up, so I'm going to multiply by 3 on both sides. And the nice thing about doing that is it cancels out my fraction. So I'm left with x plus 5 equals 21, which is a one-step equation. I'm going to show that I'm going to subtract 5 from both sides, following along with my undos. 5 and negative 5 go to 0, so I'm left with x equals, 16. Plug this back in for some quick mental math. 16 plus 5 is 21. 21 divided by 3 is 7, so we did get the correct answer. Okay, we're going to go ahead and solve number 4 together, and then I want you to try number 5 on your own. You'll pause the video, try it on your own, and then listen back for my explanation. Number 4 and 5, there's something different about these equations. The variable is on the right-hand side rather than on the left. Now remember, you can use that reflexive property of equality and just flip around how you write your equation. But honestly, this isn't a big deal. I want you to try and get used to having the variable on the other side. So we're going to solve it with the way that it's written, but I want you to know it's okay to me if you rewrite it, if you flip it. I have no problem with that. I had to do that when I was a student for quite a while until I got the hang of it. All right, so let's think through. The variable here is multiplied by negative 3. You got to be careful about that. Coefficient is negative on this one. And then we are subtracting 2. So to solve, we're going to add 2 and then divide by negative 3. Remember, when we're multiplying or dividing, we always are multiplying or dividing by the same sign because we want our goal to be positive 1. Alright, so I've got 10 equals negative 3x minus 2. Let's do our clues and undos table. I am multiplying by negative 3, then subtracting by 2. So to undo that, working from the bottom up, I'm going to add 2, divide by negative 3. Okay, so we're going to show that. Even though the variable's on the right-hand side, it doesn't matter because we're going to follow our undos, which tells me to first, I'm going to be adding 2. Add 2 to both sides. Those 0 out. I have 12 equals negative 3x. It's a one-step equation. Following my second undo, I know that I'm going to be dividing both sides by negative 3. Negative 3 divided by negative 3 is positive 1. That leaves me with x on the right-hand side. 12 divided by negative 3 is negative 4 because positive divided by negative is a negative. Quick mental math check. Negative 3 times negative 4. Negative times a negative is a positive. That would be 12 minus 2 is 10. So we got the right answer. Now I want you to try solving number 5 on your own. I think it's similar to number 3. It's just that the variable's on the right-hand side. Pause this video. I'm going to work it out and then, pause the video. I want you to work it out and then check back in to see how I did it. Okay. On this equation, we have 2 is subtracted from the variable, and then the result is divided by 5. To solve, we're first going to actually multiply by 5 and then add 2. Rewrite the equation. 10 equals x minus 2 all over 5. Let's make our clues and undos table. Remember, we're going to imagine that when that vinculum goes all the way across the terms in the numerator, that those are grouping symbols that are invisible there, which means that instead of dividing first, parentheses trump multiplication and division, so I need to subtract 2 first. My clues will list that I'm subtracting 2 first from x, and then I'm dividing by 5. To undo those, we work from the bottom up, and I'm going to multiply by 5 first, then add 2. Let's work it out. Times 5 times 5. 10 times 5 is 50 on this side. Those will 1 out, and I have x minus 2. My last step is to add 2 to both sides, and we get 52 equals x. Quick check here, 52 minus 2 is 50. 50 divided by 5 is 10. So we got it. All right, make sure you have your notes completely filled out, and it is time to move on to the worksheet. Have a great day.